Okay, good morning. Happy Wednesday. Looking at our calendar, we see that I'm looking at the wrong section. So let's try that one. Today is our first day on the quadratic formula. We're going to spend 2 days on this thing called the quadratic formula, today and Friday. Last class we looked at graphing parabolas, and today we'll kind of look back at the graphs of those parabolas and then figure out how this new formula comes into play. So Friday is new stuff, Monday is word problems, and then Wednesday, 1 week from today, is quest number 4. Questions on the calendar? 1 week from today. I think I'm reading that right. 19th. Yeah. 1 week from today. And then the exam is coming up on November 26th. What day is that? 2 weeks from today. Right. Okay. So let's jump to page 50. And we'll start way up here at the top with the daily summary. Swan, can you read the daily summary? Thank you. Kayla, 1. Okay, so we're going to look at these 4 graphs. So the first one is graph A, and how many x-intercepts do we see in this graph? We see 2 of them. So that one has 2 x-intercepts, and then go ahead and write down the coordinates of the x-intercepts. So the one on the left, what's the x-coordinate? Looks like -6. What's the y-coordinate? 0. Go ahead and write the coordinates of the other point. And hopefully we see it's 1, 0. Okay, playing the same game with graph B. How many x-intercepts do we see there? Looks like just the 1. And the coordinates of that point looks like 2, 0. So far, so good. All right, moving down the list to graph C. How many x-intercepts here? 2 again. Coordinates. What about this left one? -3.5. Are we 100% that that's -3.5? It's just an estimate, right? It's approximate. Okay, so about -3.5, comma 0. And then the other one, 1 point. I mean, to me, it actually doesn't look like it's in the halfway point. Like, I'd probably say like 1.4 or something. But anyway, just pointing out that that is an approximation, as are all the numbers that we've just written. And then finally, poor graph D, how many x-intercepts? 0, that's too bad. So the coordinates, not applicable. There just aren't any, right? Okay, so down here in number 2, let's go to Iman. Could you read number 2, please? Iman, number 2.
How many x-intercepts are possible?
All right, so we saw all the different possibilities above. What's the fewest number of x-intercepts a parabola could have? 0. And then it could have 1 if it just barely skims the x-axis, right, like graph B. Or it could have 2. Is it possible to have 3? No, can't have any more than 2. So that's all the possibilities. Let's go to Alex for number 3. Okay, so we filled these before, so I think we said -6, 0, and 1, 0. Keep going, Alex. Okay, so let's pause right there. Looking at the equation that I gave you, as well as the equation of the parabola that's in the graph, what's the only change in those 2 equations? What's equal to 0? Is the y, right? Equations are exactly the same, but the y has been replaced with a 0. Yes? Okay, so then we're looking for places on that curve where the y coordinate is 0. And what are those two places? At -6, the y is equal to 0. That's the first point that we wrote down, right? And at 1, the y coordinate is 0. So we can look at the graph and get exactly the same answers we got before. Technically, the solutions here don't include the y value at all. You just say x equals -6 is one solution, x equals 1 is the other solution, because that equation, the one with the 0, doesn't have any y's in it, so it would be silly to include any information about y's. Okay, but now suppose we don't have the benefit of the picture in front of us, because getting the picture takes actually quite a bit of work, as we saw last class, right? Drawing parabolas is a multi-step process. So suppose we don't have the benefit of the picture and we just want to solve that equation. Well, we actually did these, I think, 2 classes ago. If I'm just looking to solve the equation, then it'd be really super if I could factor the right-hand side, right? So let's take a moment to factor the right-hand side. We're going to get x squared, so that's got to be x and x. What's that? Oh, -6. Just seeing if you guys are paying attention. Good job. Okay, is this the harder box or the easier product sum? Easy, right? Because it's a 1x squared. So looking for two things whose product is -6 and whose sum is +5. Don't say the answers out loud. But if you find the answers in your head, just write them down in the parentheses. Okay, now we can say the answers out loud. What are the two numbers? -1 and +6. Either order is fine. And then we had this really nice property that we used last time, 2 classes ago, that said if you multiply two things and get 0, what must be true? One of them had to be 0. So either x minus 1 was 0 or x plus 6 was 0. And I'd encourage you not to take this little shortcut that says, oh, the answer is just the opposite of the numbers in purple. Oftentimes it is, but it isn't always. So I'd encourage you just to write that step. It takes hardly any time to do the finishing algebra, and we get x equals 1 and x equals -6. How do those answers compare with the answers we got from the graph? Same. Super. Okay, so we've done that. That's kind of a review of 2 classes ago, this factoring to solve equations. On the next page, let's go to number 4. Nate? Parabola. Okay, the two x-intercepts, this was the one that we estimated. I think we said -3.5-ish. Right, -3.5 comma what? 0. And then I think we tried 1.4 on the other side. And so if we're looking to solve the equation, 0 equals all of that stuff, exactly the same stuff. Again, what's the only change in these two equations? Is that the y becomes 0. So we figured out where the y is equal to 0 by looking at the graph and saying, oh, it's just those x-intercepts. So what are the two solutions to this equation? -3.5 is one, and 1.4 is the other, approximately. Okay, so let's see if we can do the same technique we used on the previous page, just at the bottom there. So what I'd really like to do, if I want to solve algebraically, is I'd really like to be able to take this guy and do what to the right-hand side? It's factor, right? It would be lovely if we could just factor this, and then it's the same technique we used before. So we want two numbers whose product is supposed to be -5. Sum is supposed to be +2. X and X. Product -5, sum 2. There aren't that many choices for that product of -5, and neither of them works, right? So the fact is this one just doesn't factor, and That's no surprise, actually. Most of them don't factor, and the only reason almost all of them factored on the previous night's homework was because they were selectively chosen, so you could factor them. But most of them don't factor. So we got to have some different technique. So the different technique is this thing called the quadratic formula. Okay, so who's our reader now? Let's go to Alex in the front here. Alex. Yes. Thank you. Jasper? The thing in the box. Okay, so there's a quadratic formula. Raise your hand if you've seen it before. It looks like everybody. Raise your hand if you could write it down without looking at that. I think you have it in your head already. A few of us. It's okay. A few of us. All right. So let's actually use the formula, and then I think we got a serenade coming in the back. I think Iman said he's going to sing the song for us. I'll join you. All right. All right. Okay. So let's. Not at all. Very, very late. Okay, so let's take a look at this equation. We're going to solve it using this quadratic formula. So step number one, if necessary, put the equation in standard form. That is to say you have a 0 on one side and then the rest of it is in decreasing order. The power is x squared and then x and then just a constant. And so fortunately for us, it's already in that form. Step two is to identify and write down the values for A, B, and C. Now, I'm not going to mandate this, but let's just go ahead and write them here because it's our very first one. So if you can use the quadratic formula without writing these things down explicitly, that's totally fine. So remember, A is always the number touching the x squared. How much is A in this one? It's 1 because there's an invisible 1 in front of the x squared. B is always the number touching the x. It's 2. I'm going to start getting in the habit of writing the plus signs even when they're invisible, because whether A, B, and C are positive or negative has a big impact on the actual answer. And then C is the constant term with no x, and it's -5, right? Really important to include that negative. Okay, and so now let's use the quadratic formula. There it is written out again. So -b, that just means take the opposite of b. What's the opposite of b? -2. Then you copy the plus or minus, then you copy that big square root. And then we're going to do b squared. Now, you're welcome to do this in your head if you want to, but I'm going to write all the details. So b squared is a +2 squared. And then -4 times, how much is a? +1. And how much is c? -5. So that's my b squared minus 4ac. All divided by 2a, 2 times +1 in this case. So there's the substitution step. All the a's, b's, and c's get replaced by numbers. Now, I know that for some of you, if you see anything with numbers in it, you immediately go to the calculator. I'm going to encourage you to not go to the calculator if the numbers are manageable. It is very easy to make a mistake when you type in this complicated thing on the calculator. And I think that you guys are probably more accurate by hand than you are with typing a massive thing like that into the calculator. So let's give this a shot. We'll use the calculator at the end. -2 plus or minus square root of, how much is 2 squared? 4. Okay, I've got a 4 times 1 times -5. Forgetting the signs, how much is all that? 4 times 1 times 5 is 20. So I'm just going to put a 20 with a space in there that I have to fill in. I encourage you to separate the number calculation from the sign calculation. How many negative signs do we see? 2, I'm counting that subtraction sign as one of my negatives, and 2 negatives make a positive. So that is a plus in there, but it's a really common place to make a mistake. To put the wrong sign. So you're just counting signs. An even number of signs we know is a plus. Divided by 2 times 1 is just 2. And so this is equal to -2 plus or minus square root of 24, all divided by 2. Any questions so far? Okay, now for some problems, this is the end of the game, but our obligation is to simplify this as far as possible. And in fact, a few sections back, maybe like 2 weeks ago, I actually gave you things that looked just like this. There was no context back then. I just gave you stuff and I said, we're going to simplify this. And so the reason we did that back then was for this moment right here. So we're going to simplify and hopefully it'll look familiar because we did it a few weeks ago. -2 plus or minus square root of. 24 is not a perfect square. I don't see it up here in my yellow list. But if you see a perfect square that goes into 24, then good things happen. So what perfect square from this bottom row goes into 24? It's 4. And so we write 24 as 4 times whatever's left. Happens to be 6, right? And then we know that square roots work really nicely with multiplications. So in my mind, I'm splitting this up into 2 square roots. Square root of 4 times square root of 6. And that square root of 4 comes outside as 2. So we go -2 plus or minus. Square root of 4 comes out as 2. Square root of 6 is still there. I'll put a little dot to make sure we're clear that it's multiplication. And then the next thing that I encouraged you to do 2 weeks ago was split this up into 2 fractions. So this equals -2 over 2 plus or minus 2 root 6 over 2. Do you remember doing this? Split into 2 fractions, and then it's safe to simplify each fraction separately. So -2 over 2 is -1 plus or minus 2 root 6 over 2 is just root 6, and the denominators all happen to disappear. And I'll just point out that on the last quests, which I know I still have to give back to you for keeps, I'll do that as soon as I can. But on the last quest, there was a problem that kind of looked like this one. I think it was actually the last problem on the quest. And a bunch of people did this. They said, okay, 2 cancels with -2. And my answer is -1 plus or minus 2 root 6. It wasn't these numbers, but it was that idea. But you cannot just take the denominator and put it into only one of the things on top. It's underneath both things on top. And so that's why I thought it was a good idea always to split into 2 fractions. So this is our simplified reduced answer. If we also want a decimal, and I think this problem also said give me a decimal rounded to the nearest hundredth. Let me highlight some stuff here. The exact answer is this. And now we're about to do the decimal part. Iman, you ready to sing? Yes. So we're going to do that right now. That's what we're doing now. Okay, so the exact answer is there. The rounded to the nearest hundredth we're about to do. So what does this really mean, that plus or minus? It really means, and I'm going to write -1 plus root 6 and -1 minus root 6. And if you write the two of them down, then it's really easy to type them into the calculator. But you do them separate. You can't do them both in one shot. And so then we'll just type this onto the calculator, into the calculator. How much? 2.45 for this one. And then -3.45. Is that right? So the reason they're not like the same number but opposite is that that -1 throws things off. It's not just root 6. Oh. Okay. 1.45. Yeah, so you got to do the -1 plus that square root. It's not just the square root of 6, but it's -1 plus the square root of 6.
Right, we've been doing everything in little steps.
And then we said, you know, we're done with this. One big step. Yeah. Okay, and if you have trouble typing that in your calculator, just let me know in a little bit. I'll come around and help you. But part of what I need you to be able to do is get the decimals. Questions on this? Okay, So then let's go to the next page. We'll do one more example together and then the activity. Okay. What? What went? We will. It's coming. The lyrics are right below this problem. Until you get serenaded. All right. So we're ready to do number 9. Okay. All right. We got the lyrics. I guess we have to sing now. Okay. So let's try number 9. Let's try number 9. Okay. So the fractions, I would encourage you to get rid of the fraction as the very first step. You're welcome to use the 7/3 in the quadratic formula, but it will be quite messy. It will get you to the right answer eventually. But I would encourage you to multiply both sides by LCD. What is that called? What does that stand for? Lowest or least common denominator, right? Okay. And so in this case, the only denominator is 3. So let's multiply both sides of this equation by 3. 3 here, 3 there. And it's important to recognize that the 3 doesn't just cancel that 3 on the 7/3, but it first multiplies both terms on the left, right? So that 3 hits the 2x squared and becomes 6x squared plus. Then we multiply the 3 times the 7/3, and in our minds right away cancel those 3's and just get the 7 with the x. Okay, so this is not a hard step once you know how to do it, but make sure you see that this distributing happens first, and then the 3's cancel in one term. Okay, the right-hand side. It's 3. It's really easy to put a 1 there to forget that you have to do this thing to both sides. Okay, it's looking better, right? No fractions. Is it in standard form right now? No, what do we need to get? 0, so we'll subtract that 3. Okay, so this is now a brand new quadratic formula, and a quadratic equation in standard form. So how about we essentially just call the rest of this problem part of the activity? So some of you are already started, so work through this one, check your answers with your neighbors. In a moment, I'll put the answer up here, and then keep on going right to the activity.